Part one of this lecture, I'd like to talk about pertinent soil constituents relative to addressing agricultural soil suitability. And as I said earlier, these include organisms, mostly vegetation, topography associated with the soil, and parent material. Effects of soil variation across the three principal Minnesota biomes on agricultural suitability relate to soils associated with what was originally a coniferous forest, soils associated with what was originally deciduous forest, and soils associated with what was originally grassland, prairie landscape. Coniferous forest soils tend to have shallow topsoil horizons, not very much topsoil at all. They have low nutrient and acidic soil conditions from the coniferous vegetation that's growing in the soil. So there's a soil-plant interaction that tends to produce low nutrient, high acidic conditions in the soil itself. And as a result, these soils in coniferous forest conditions tend to have lower inherent fertility for agriculture. Deciduous forest soils, soils in which deciduous forest evolved, tend to have deeper topsoil horizons. They tend to be more moderately alkaline soil conditions from the deciduous vegetation itself, and they tend to have moderate fertility for agriculture. Soils evolving in grassland or prairie conditions tend to have a much deeper topsoil horizon. In this case, approximately almost a foot of topsoil, but in some locations the topsoil was as much as 8 to 10 to 12 feet deep. They tend to have alkaline soil conditions as a result of the prairie vegetation, much higher organic matter content, and as a result, these are the soils that have the highest fertility for agriculture. Topography influences soil suitability in the context of soils along a slope profile have varying characteristics and suitabilities for use in agriculture. Soils at the summit of a hill are level and easy to farm, but they may have shallow topsoil due to erosion losses. They may be droughty for agriculture as well. Soils along the lower and foot slopes tend to be shallower, especially in the side slope area. They tend to have steepness that make it hard to work and manage the soil, and because of their steepness, their higher level of steepness, they may also have a higher erodibility. Finally, soils at the toe of the slope, these are bottomland areas, they tend to have a very deep topsoil level. They tend to be more level in terms of slope conditions. They are much more moist, and in that sense, they can be both beneficial for agriculture because of their high moisture content, but at the same time, they may have too much water and be too wet for many kinds of agricultural pursuits.